In the next 10 to 15 minutes, I am going to explain how to calculate saturation current if a supply voltage and diode voltage is given. For that, if the resistor sustains a voltage of Vx by 2, how to calculate the value of supply voltage if the saturation current is given. And next, we'll take the case where supply voltage and supply currents are given, how to find out resistance and saturation currents. And finally, if the saturation current is given for a parallel resistor diode combination and the supply currents are given, how to find out the diode voltage. So now let's start with the 21st question. They say that suppose D1 in figure 2.42 must sustain a voltage of 850 millivolt for Vx equals to 2 volt. Calculate the required Is. So we know that Ix is Vx minus Vd by R1. We need to calculate saturation current. So let's find out the supply current first. Vx is 2 volt, Vd is 0.850, R1 is 2k. The Ix will be 2 minus 850, 0.850 by 2000. It is 5.75 into 10 power minus 4 ampere. Now we know that the diode current is equals to Ix, that is equals to Is times exponential of Vd by Vt. Ix is 5.75 into 10 power minus 4. Is we need to calculate. Vd is 0.850, Vt is 26 millivolt. So Is will be uh, 0.850 by 0.026. It's 3.644 into 10 power minus 18 ampere. Okay. Now let's go to the next question. So they say that for what value of Vx in figure 2.42 does R1 sustain a voltage equal to Vx by 2? Assume Is equals to 2 into 10 power minus 16 ampere. So they gave voltage across the resistor is Vx by 2. That means V input, that is V, that's equals to Vx equals to Ix R1 plus Vd. This is Vx by 2. That means Vd is Vx by 2. Okay, that is equals to Ix R1, that is equals to VR1. Correct. Now Is is given 2 into 10 power minus 16 ampere. We need to find out Vx, right? Okay. So Vx will be VR1 plus Vd. If Vd is VR1, then it will be 2 VR1. That means it is 2 Ix R1. Okay, let's keep this aside. Now Vd is Ix R1. Vd can be written as Vt ln Ix by Is equals to Ix R1. So Ix can be written as Vt by R1 into ln Ix by Is. Usually Ix is the diode current, usually will be in milliamperes. Okay, so let's take a starting value as 0.5 milliamperes. So it will be 26 into 10 power minus 3 into ln Ix will be 0.5 into 10 power minus 3 by Is is 2 into 10 power minus 16 by R1. R1 is 2000. So it is 3.711 into 10 power minus 4. Taking this as the input value for Ix, we'll iterate it with a new value. So doing this multiple times iteratively, we get a saturated value that is 3.67 into 10 power minus 4 ampere. Now using this, we'll calculate diode voltage, supply voltage, that is 282 into Ix R1. So it will be 2 into 3.67 into 10 power minus 4 into 2000. So it will be 2 into 3.67 10 power minus 4 into 2000. It is 1.468 volt. Okay. Now let's go to the next question. They say that we have received the circuit shown in figure 2.43 and we wish to determine R1 and IS. We know that Vx equals to 1 volt. That gives Ix equals to 0.2 milliampere. And for Vx equals to 2 volt, that gives Ix of 0.5 milliampere. So we need to calculate R1 and IS. Okay. Vx is equals to, writing KVL, we get Ix R1 plus Vd. Okay, so Vx is 1 volt, Ix is 0.2 milli R1 plus Vd will be Vt ln, direct current is Ix only, so 0.2 milli by Is. Okay, for 2 volt it is 0.5 milli R1 plus Vt ln 0.5 milli by Is. Okay, we need to eliminate Is in first case so that we can calculate R1. Okay, we can send this term this side on both the equations. We get 1 minus 0.2 milli R1 and 2 minus 0.5 milli R1 equals to Vt ln 0.2 milli by Is into ln 0.5 milli by Is. Now let's divide this ln by, no. We need to subtract these two so that ln A minus ln B becomes ln A by B, then Is will be cancelled. Okay. So 2 minus 0.5 milli R1 minus 1 plus 0.2 milli R1 equals to, Vt will be cancelled, ln 0.2 milli by 0.5 milli. Okay, so this is 1 minus 0.3 milli R1 equals to ln 0.2 milli by 0.5 milli. Okay, so we forgot a Vt term here, and then there should be an inverse because we are subtracting equation 2 with equation 1. So it will be 3253.92 ohm. Okay, now using this R1 value, let's calculate the Is. It will be 0.2 R1 equals to Vt ln 0.2 milli by Is. So yeah, it will be 1 minus 0.2 into 10 power minus 3 into R1 is 325.3.92 divided by 26 into 10 power 26 into 10 power minus 3, 13.431, 0.2 milli by Is. This will be e raised to this and then 0.2 by this one. Okay, 0.2 into 10 power minus 3 by e raised to 13.431. Okay, so Is will be 2.9377 into 10 power minus 10 ampere. Okay, now let's do our last question. They say that figure 2.44 depicts a parallel resistor diode combination. If Is equals to 3 into 10 power minus 16 ampere, calculate Vd1 for Ix equals to 3 different values. Okay. We need to calculate Vd1. Vd1 is Vt ln diode current Id. Let's say this is Id. This is IR. by IS, and IX equals to IR plus ID. So we need to find ID so that we will get VD. Correct. So ID becomes IX minus IR. IR is again IX minus VD by R. So this can be solved iteratively. Let's take VD as 0.768 because this is the barrier potential at 300 Kelvin. We get ID equals to IX will be 1 millivolt. Let's start with the first value minus 0.768 by R1 will be 1000. So it is 10 power minus 3 minus 0.768 by 1000. It is 2.32 into 10 power minus 4. Using this value, we will calculate VD. ln 2.32 into 10 power minus 4 by IS is given as 3 into 10 power minus 16. So 26 into 10 power minus 3 ln 2.32 into 10 power minus 4 by 3 into 10 power minus 16. It will be 0.711 volt. Usually we'll do for more iterations, okay, to get a saturated value. Using this VD as the new value, we'll calculate new ID, that is 1 milli minus 0.711 by 1000. So it will be 10 power minus 3 minus 0.711 by 1000. It is 2.89 into 10 power minus 4. And VD equals to VT ln 2.89 into 10 power minus 4 by 3 into 10 power minus 16. So the new VD will be 2.89 into 10 power minus 4 by 3 into 10 power minus 16. It is 0.717. Using the newly calculated VD value, we will calculate new ID values. Okay. So this is how we'll calculate diode voltage for different types of supply voltages and supply currents. So now I'm restricting this calculation only for one value of Ix. You can do for the rest of the supply currents. So yeah. So in this video we have learned how to calculate diode voltages if other parameters are given, and supply currents, and how to calculate resistance value, and how to calculate saturation currents. That's it for today. We'll solve more problems in the upcoming videos. Bye. We'll meet you in the next video. Bye.